Hello algebra students, this is Mr. Von Ah coming back to you with some more algebra, and we are doing some very exciting stuff. We are learning how to complete the square. So this is our last lesson on completing the square, and so our objective here today is that we're going to learn, finally, completely, how to solve quadratic equations by completing the square. The cool thing about this method is you can use this method for any quadratic equation. You're not limited. All right? So what I have here is I have a couple of examples that we're going to do in this video. And each of them are a little bit different, so I wanted to share them with you. All right, so let's take a look at the first example. I have x squared plus 4x minus 2 equals 0. This question, is this in standard form? Yes, it is. It's in descending order. A is a positive number, and it is set equal to 0. So step 1 is done. All right, let's see if we could, we've learned how to solve by using principle of zero products. Let's see if that works for this one. All right, so our next step would be to factor, right? So we'd set up our x, all right, and our ABCs, remember this? A is 1, B is 4, C is negative 2. All right, so remember here it goes AC, so it would be 1 times negative 2, which is negative 2, and B is 4. All right? So question, what two numbers will multiply to give me negative 2 and add or subtract to give me 4? Can you think of any numbers? Well, the only way I get 2 by multiplying is 2 times 1, correct? And one of those has to be negative. 2 minus 1 is 1, not 4. Even if I did 2 plus 1, it would only give me 3. This is not factorable. So I cannot use principle of zero products to solve this. I would be stuck. But thankfully, we have other methods. We have completing the square. All right, so let's try that with this one. All right, so our first step for completing the square is that we want this trinomial to be a perfect square. Now, how do we make a perfect square? Well, remember, this C is the key. Okay, do you remember our little formula for finding the correct C, the correct number here, to make this a perfect square? Remember, it was C equals B over 2 squared. All right, that's a critical little formula. Okay, so what does C need to be? Well, okay, well, B, what's B? B is 4 over 2 to the second power. So C needs to be, well, 4 divided by 2 is 2. 2 squared is 4. So this number right here needs to be a 4, right? Needs to be a 4. But unfortunately, it's a negative 2, isn't it? Okay. Well, what could we do to turn this negative 2 into a 4, a positive 4? What would we need to add? Well, if we only added 4, that would only make this 2, right? So in order to make this a 4, we need to add 6. Right? Because negative 2 plus 6 is 4. All right, we want this to be a 4. Okay, so we added 6 to the left. We have to also add 6 to the right. All right, and again, the reason why we're doing this is because we decided that to make this a perfect square, our C needed to be 4 divided by 2 squared, which is 4. It needs to be a 4, but it's a negative 2. So by adding 6, that will make it a positive 4. All right, so let's go ahead and bring down our new polynomial equation here. So we got x squared plus 4x. All right, negative 2 plus 6 is going to give us that positive 4 that we were looking for. And 0 plus 6, of course, is just 6. Okay. So now we can go ahead and factor this guy right here. Okay, so let's go ahead and do that off to the side here. So A is 1, B is 4, and this time C is also 4. All right? So AC goes right here, and B goes here. So 1 times 4 is 4, and B is 4. So what two numbers multiply to give me 4 and add to give me 4? Well, that's an easy one, huh? 2 times 2 is 4. 2 plus 2 is 4. So that's going to be those are going to be our numbers, 2 and 2. Okay, so we can factor that here. So to factor x squared is just x times x. And then these are going to be our two magic numbers. Plus 2, plus 2. I got plus because these are positive 2's. Okay, and don't forget, this is an equation. Set it equal to 6. Okay, so now you notice that we have two sets of x plus 2's. We can write that in exponential form, right? 2 to the second power is, or 2 times 2 is 2 to the second power, etc. So I can write this as x plus 2 to the second power, right? Equals 6. All right, so we're getting closer to solving for x. Remember, our goal here is we want to solve. We want to solve for x. All right, so I have x plus 2 squared. How do I get rid of that square? If you remember, the inverse of a square is a square root. I do that to both sides. Okay, the square root of x plus 2 squared. Remember, the square and the square root disappear. And I'm left with just simply the x plus 2. And that's going to be set equal to, well, what's the square root of 6? What number squared is 6? I can't think of one either. Some irrational number. Decimals. So here's what I'm going to do. I'm going to leave it like that. I'm going to leave it as square root of 6 because it's not a perfect square. Right? If that was a 4, well then the answer would be 2 or plus or minus 2. Okay, so here's what we're going to do. We're just going to leave this under the radical, but remember that all positive radicands have two real number solutions, plus or minus. All right, so x plus 2 equals plus or minus the square root of 6. All right, so now in order to solve this, we need to get rid of a plus 2. To get rid of a plus 2, simply subtract 2 to both sides. Okay, that's going to cancel, leaving you with x equals. Now, can I add these two? Can I just go like 6 minus 2? I can't do that because this is not a 6. Looks like one, but it's not. That's the square root of 6. Kind of like if it was the square root of 4. Well, the square root of 4 is really not 4, is it? The square root of 4 is 2. Okay? So I can't just add the 6 with the 2 or subtract them. Can't do it. I have to leave them separated. Okay, and here's how I would write it. I'd put the regular integer out in front. So it'd be negative 2 plus or minus the square root of 6. And that's your solutions. Those are your solutions. Now, in case you're wondering what that means, you probably are wondering, what in the world does that mean? Let's go ahead and approximate this. All right? So what is the square root of 6? Well, I'm going to give you a decimal approximation with my calculator. The square root of 6 is about 2.45. Okay? It's about 2.45. All right, so I'm going to go ahead and fudge over here a little bit. So this is basically x equals negative 2 plus, what did I say it was? 2.45? Or x equals negative 2 minus 2.45. Where did I get the 2.45? That's approximately what the square root of 6 is. All right, so if I go negative 2 plus 2.45, I get x, it should be approximately equal to, well, negative 2 plus 2 is 0, plus 0.45 is 0.45. So x is approximately 0.45. And here, negative 2 minus 2.45, well, when you got the same sign, you just add them up. So I'd have negative 4, negative 4.45. Those are my approximate solutions. This is my exact solution. So when you're doing problems, you have to look and see what are they looking for an answer. Are they looking for an exact answer? You would write it like this. If they're looking for a decimal approximation, you would write it like that. All right? And again, I don't have room to show this, but these are just the x-intercepts for the parabola. It's just where the parabola crosses the x-intercept. It crosses at about 0.5 and about negative 4.5. Okay? So that's one example. Okay, pretty straightforward. Let's try a second example. It's going to involve one extra little step. All right. So I have here, I can just tell you right now, I can't use principle of zero products on this. Because I'm looking at this, 4, the only way I get 4 by multiplication is 4 times 1. And 4 plus 1 does not get me 8. It gives me 5. And 2 times 2 is 4, but 2 plus 2 is not going to get me that 8. All right, so I'm not going to be able to use zero products on this. So I'm just going to go completing the square. Okay, so I need to figure out, okay, what does C need to be for this to be a complete square? Well, let's see. Let's do that C thing up here. C, remember C equals B over 2 squared. So C equals B, which is 8 over 2 to the second power. So C needs to be 8 divided by 2 is 4. 4 to the second power is 16. All right, so C needs to be 16 for this to be a perfect square trinomial. The problem is it's not 16, it's only 4. Okay, how do I make it a 16? Well, very simple. If you got $4 and you need $16, how much money do you need to borrow? You need 12 bucks, don't you? So I'm going to add $12 to this guy's account. Now he's got 16. But here's the deal. You got to do it to the other side as well. Okay? So let's go ahead and bring down our results. So I have x squared plus 8x plus 4 plus 12 is 16 equals 12. All right. So now I have a nice perfect square trinomial. And when you start getting good at these, you'll be able to do them in your head without even making these little x's. But we'll just continue to make an x here. Okay, so let's make we don't have any room for an x, but let's do it right here. Okay, so A is 1, C is 16, so 1 times 16 is 16, and B is 8. Okay, so I need to think of two numbers, multiply to give me 16, and add or subtract to give me 8. Well, let's see, 4 times 4 is 16, 4 plus 4 is 8. By the way, a little hint, If this is a perfect square trinomial, these two numbers will always be the same. Just like in a square. A square, the sides are always the same. Okay? So I know that's the case here. 4 and 4. So now I can just factor this. X plus 4 times x plus 4 equals 12. All right? You can see that's a square, right? The length and the width are exactly the same. All right, so now I can write this as exponential in exponential form, just like I did over here, right? So x plus 4 times x plus 4 is the same as x plus 4 to the second power. And that's going to be set equal to 12. All right. Now I need to get rid of that square, right? How did I get rid of the square over here? The inverse of a square is a square root. So let's go ahead and take the square root of both sides. So the square root of x plus 4 squared, remember the square root and the square are going to cancel each other out. And I'm just going to be simply left with x plus 4. All right, so I got x plus 4 equals plus or minus the square root of 12. All right, remember there's always that plus or minus. You have two solutions. Okay, so now I got to get rid of that 4. Okay, before we get rid of that 4, maybe it'd be a little more clear if we did something here first. Okay, I want you to notice something. That's a 12, right? Now if I think, what's the square root of 12? Okay, I don't know what it is. Square root of 9 is 3. Square root of 4 is 2. All right, those are perfect squares, but 12 is not a perfect square. But here's the trick. It has a perfect square in it. Right? If I were to factor 12, okay, what are the factors of 12? Let's do this over here. I could factor it as 12 times 1, but that's not going to really help at all. I could factor it 6 times 2, or I could factor it as 4 times 3, correct? Okay, look at 6 times 2. Are there any perfect squares in there? What's the square root of 6? It's not going to be a perfect square, right? It's going to be an irrational number. This one's not helpful. 2 is not helpful either. Square root of 2 is like 1.414, blah, 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 forever. But look at this. 4 times 3. Do you see a perfect square in there? Do you see it? I see a perfect square. Right there. 4 is a perfect square. The square root of 4 is a whole number, right? It's 2. So what? Here's the trick on this one. I'm going to go ahead and factor 12 so that I can pull out the perfect square. Because here's the bottom line. We want as little under that radical sign as possible. Because radicals are difficult. They're complicated. We'd rather work with whole numbers and integers. Okay, so the smaller this number, the better. Okay, so we're going to factor this as, let's see, x plus 4 equals plus or minus the square root of 4 times the square root of 3. And this is getting a little boggled up in here. So I'm going to erase that. So all I did is I factored 12 and I put it into two different spots. 4 times 3 is 12. And they're both square rooted, right? So we're good. Okay, now we know the square root of 4 is plus or minus 2, right? But the plus or minus is already there. So I can bring that down. So x plus 4 equals plus or minus the square root of 4 is 2. Now root 3, that's not a perfect square, is it? So we're going to leave him alone under his radical. He's just too radical to come out. All right, so now I have one more thing to do. I need to take care of that 4. Okay, we need to solve for x. So let's subtract 4 and subtract 4. Okay, that's going to cancel. All right? So we're going to end up with, I'm going to put it over here, x equals -4 plus or minus 2 times the square root of 3. And there's your answer. Okay? Note, I cannot add or subtract 4 and 2. Can't do it. Here's why. That 2 is being multiplied by that square root of 3. Right? If I were to say this, if I said 4 plus 2 times 3, if I had 4 plus 2 times 3, would it be legal to go ahead and add 4 plus 2 first? Can't do it, right? You'd have to multiply order of operations and then add. Okay, but we don't want to multiply these. We want to keep them like they are. Okay, so that's going to be your final solution. That's the exact solution. Again, if you want to get a decimal approximation, just find out what's the square root of 3, multiply that by 2, and then either add it to 4 or do 4 minus that quantity, and you'll get your 2 decimal approximations. Okay, that's going to pretty much require a calculator. Okay, so that's the gist. This is how you solve quadratic equations using the principle of completing the square. And again, you can use completing the square to solve any quadratic equation. You're not limited. All right, so I hope this video was helpful to you. Make sure you subscribe if you haven't done so already. That way you get notices whenever I make new videos. And until then, may God bless you, my friends.